3.4, solve equations with variables on both sides. So essentially this is just a continuation of what we've been doing in 3.1 to 3.3, where we did one step, two step, multi-step, and now there's going to be variables on both sides and we have to move things around to do that. When we do this, the big thing that we need to do is we need to get variables on one side and constants, meaning just the numbers, on the other side. It is possible that a problem can have more than one solution or no solution. So if we have let me see how to put this. An equation that is true for all values of the variable is called an identity. So that would be something like if we get a result 8 equals 8, 0 equals 0, -3 equals -3, something like that would be an identity. Some equations will have no solution, meaning no value of the variable will make it true. That would be something like -3 equals 7, or 0 equals 8, something like that would be no solution. So some of our problems today will potentially be an identity or no solution, and so you'll have to state what it is. If we get to something that's like 8 equals 8, then you need to say your answer is that it's an identity. If it's something like -3 equals 7, then you need to say no solution. That's how you get the answer completely right. So moving into examples, and I will reiterate yet again, you must show your work like I do or you won't get all the points. Say it with me. We must show the work like I do or you won't get all the points. Are there any questions about that? Okay.
Wait. Are you sure your work?
She's about to show us what
Have I done a problem yet? Okay. Number 4, solve the equation. K plus 1 equals 3K minus 1. Now, what I'm going to let you do to shorten some of your work a little bit is that I'm going to let you do 2 things at one time. If you feel like you can't do 2 things at one time, then I suggest you do them separately. But I need to get all the variables on one side and all the numbers on the other. I like my variables on the left, so I'm going to move all the variables to the left, all the numbers to the right. So I'm going to subtract 3K from both sides. And at the same time, I'm going to subtract 1 from both sides. Okay? So I'm moving this 1 over here, and I'm moving this 3k over here. So over here now I have k minus 3k is negative 2k equals negative 1 minus 1 is negative 2. Now divide by negative 2. K equals 1. So if you want to move two things at the same time, that's fine. It'll just save you an extra step. But if not, I'll do the next one where you show everything out step by step, like not doing multiple things at the same time. Number 6, 8 plus 4m equals 9m minus 7. So I'm going to move my variables to the left first. So I'm going to subtract 9m from both sides. So I will get 8 minus 5m equals negative 7. Is this funny?
No.
Okay. I'm going to subtract 8 from both sides now so I get the numbers over here by themselves. So negative 5m equals negative 15. Then I'm going to divide both sides by negative 5. So m equals 3. Okay, so this is where I did one thing at a time. You can see there's like essentially a whole extra step in here compared to if I do it all at the same time. So it's up to you, whatever you feel like you need to do to keep the answer straight. But if you feel like you can handle doing it at the same time, it just speeds it up a little bit.
So do you just subtract the larger variable? Like,
I just want my variable on the left, but I could do it the other way. It doesn't matter. I'll do the next one the other way, so I move it to the other side just so you can see it. Watch, it's probably still going to be the bigger one, but no, it won't be. Okay. 8. 19 minus 13p equals negative 17p minus 5. So if I wanted to move and say put the variables on the right instead this time just for fun, I can add 13 to both sides. So I'm moving my variables to the right, I'm moving my numbers to the left this time. So I'm going to add 5. Is everybody tracking when I do the stuff in the same step?
yeah.
Okay. So then I have on the left, the 13p's cancel each other. 19 plus 5 is 24 equals negative 17p plus 13p is negative 4p. 5's cancel over here. So then now divide by negative 4. So p equals negative 6. So I can write it the other way, that's fine. I just am a creature of habit and like variables on the left, but that's totally up to you. Do you have a question? Nope. Okay. All right, 10. 5h minus 7 equals 2 times h plus 1. So I'm adding another, like, basically step in here. What am I going to have to do first and foremost for this problem? Distribute. So when I distribute, I'm going to have 5h minus 7 still on the left. On the right, 2h plus 2. Now what do I do?
Subtract 2h.
Subtract 2h. What else can I do? Just to save a second. Add 7. Stuff has to go opposite. So then 5h minus 2h is 3h. 7's cancel. On the other side, 2h's cancel. 2 plus 7 is 9. So I have 3h equals 9. Divide by 3 on both sides. So h equals 3. All right, 14. 5 times n plus 2 equals 3 over 5 times 5 plus 10n. So now I have to distribute on both sides. What happens, or what do I get when I distribute on the left?
5n plus
5n plus 10 equals what happens when I distribute this 3/5 over here?
3 plus 6n.
Yep, 3 plus 6n. So this being a fraction, the 5's basically cancel each other out, and I'm left with 3. And then when I multiply by 10n, the 10 and the 5 reduce down to be left with a 2 times 3 is 6, and then obviously the n goes with it. I feel like we've been having a little bit of issues when we've been multiplying, like distributing a fraction with other stuff. So just make sure we pay attention to that. All right, what do I do now? And I don't care if we go left or right. Tell me which, like, what you want to do. Minus 6n. What else can I do?
Minus 10.
Minus 10. So when I do that, I get what?
Negative 1 and
equals negative 7.
Now what do I do? Divide by negative 1. So I get n equals 7. All right, any questions about those so far? All right, so now we're going to move into ones that say solve the equation if possible. Okay, so if you see that, that means that some of them may produce no solution, some may produce the identity, and some may just produce a number like what we've been getting. Okay, so let's start out with 18. W plus 3 equals W plus 6. So when I do this one, I'm going to basically work just like I've been doing the other ones. Subtract W, and then subtract 3. W minus W is 0. 6 minus 3 is
3.
So if I get something that 0 equals 3, what do we say that is?
No solution.
No solution. So you need to show, and I'll a lot of times write solution like this. I think I've done this in here before, but you need to write that 0 equals 3, or, you know, whatever direction you went. It's going to make a false statement. If you had subtracted the 6, it's going to end up being a negative 3 equals 0, which is also fine. But you need to show that false statement and then say that it's no solution to get all the points for that. Okay? 20. 8z equals 4 times 2z plus 1.
You have to do the distributive function.
Yep. So what do I get when I do that?
8z plus 4
Now what?
minus 8z.
Minus 8z. So I get 0 equals 4, which is
No solution.
no solution. Uh, 24. 12y plus 6 equals 6 times 2y plus 1. What do I do here?
Distribute.
And what do I get when I do that?
12y plus 6.
What do you notice?
They're the same.
They're the exact same thing, so you can immediately, once that happens, say it's an identity. As soon as you get two things that are exactly the same, You don't have to keep going. If I kept going and subtracted on both sides, I would end up with 0 equals 0, which is still an identity. It's a true statement either way. 3 equals 3, 27 equals 27, however you do it. It's an identity. All right, let's jump to some that are adding a couple more steps to it. 30. 8w minus 8 minus 6w equals 4w minus 7.
Now let's combine like terms.
Yep, let's combine like terms first. So anytime I have like terms on a side, I should simplify everything down first before I start moving things around. So when I combine like terms, what do I get? 2w minus 8 equals 4w minus 7. Now what? Minus 4w on both sides. And what else?
Plus 8.
Plus 8 on both sides. And what does that give me?
Negative
Negative 2w equals negative, no, 1.
Positive 1. Negative 7 plus 8 would be positive 1. Now what?
Divide by negative 2.
Divide by negative 2. So my answer is w equals negative 1/2. Let's do 34. 5/8 m minus 3/8 equals 1/2 m plus 7/8. So this one obviously has our favorite thing in the whole world, fractions. Okay.
Decimals are better.
So, fortunately, almost all of these things have what?
Like terms.
8, so a common denominator. So that makes life a little bit easier. But what do I need to do with this one first?
Minus
Make 1/2
1/2
4/8.
Okay, I can make 1/2 into 4/8 if I want to do it that way. So I'm going to rewrite this as 5/8m minus 3/8 equals 4/8m plus 7/8. Now, you don't have to do that very first, like as the very first step. You could wait until you actually move it around, but totally fine to go ahead and get the common denominator. So, what do I do now?
Subtract 4/8m.
Subtract 4/8m on both sides. What else?
minus 3/8.
Plus.
Plus. Plus 3/8. And so when I do that, 5/8 minus 4/8 is 1/8 m equals 7/8 plus 3/8 is
1 and 1/4.
10/8. I would leave it like this until the problem's done, because what do I have to do over here now?
Divide.
Wait, don't multiply.
By
8.
8, because that's like doing 8 over 1, which means everything cancels over here. Multiply by 8 over here, and what happens?
You get 80 over 8.
So this cancels, and I'm left with 10. So not actually that bad, even though it looked a little scary at the beginning, right?
Yes. Indeed.
All right, are there any questions about these?
No?
All right, one last thing I want us to do. Find the perimeter of the square. So if I'm finding perimeter of a square, what is my general equation for the perimeter of a square? What'd you say?
P times 4.
Yes, well, side times 4. So 4 times the side length. So they give us a square. And they tell us that this side is 8x minus 10. And they tell us that this side is 6x. What do I know about the sides of a square?
They're equal.
They're equal. Any idea what I should do to start this problem then?
There's also.
Do what?
Or you put all the sides of 6.
No.
Because x is also.
If I didn't have x, it
Hear
would
me
be a
out,
little
like
bit.
terms. Hear me out, like terms, guys.
So I know that all the sides are equal, so what should I do with the two sides that I'm given?
Make them into an equation. So like 8x minus 10 equals 6.
Yep, so I want to set them equal to each other. Now, we haven't had one like this. If I have something where there's only like one constant term, I'm going to move my variables away from the constant term and not be moving everything around. I don't want extra moving pieces. So I'm going to move the 8x to the right. So minus 8x. So negative 10 equals, what is that? Negative 2x. Divide by negative 2. So 5 equals x. So that means if I plug in 5 over here for x, what is this side length going to be? 6 times 5 is 30. If you want to check it and verify, you can plug it in this one. 8 times 5 minus 10 is 30. But now remember, I want perimeter is what it asks for. So I need to take this side length that I got and multiply it by 4. So 4 times 30 is 120. So that would be the answer that it's looking for. Okay, so that's kind of applying what we've been doing to be able to do that. Any questions on that? All right, your problems are 3, 7, 11, 13, 19, 23, 25, 31, 33, 35, and 37, and then one square problem, 45.